Okay, I have one last example for you to kind of put together a whole bunch of ideas. So the idea of insurance is that we all face risks that are unlikely but carry high cost. Think of a fire or flood destroying your apartment. Insurance spreads the risk. We all pay a small amount, and the insurance policy pays a large amount to the few of us whose apartments are damaged. An insurance company looks at the records for millions of apartment owners and sees that the mean loss from apartment damages in a year is mu equals $125 per person, with a standard deviation of sigma equals $500. So what that's indicating is that most of us have no loss. So our value here is 0, and a few people lose a whole lot of money. So I want you to think about how that population distribution is going to look. Is it left skewed, right skewed, normal? And then there are some questions here. Would there be any statistical concerns if the company only sold 12 policies? And if the company sells 10,000 policies, can it safely base its rates on the assumption the average loss will be no greater than $136? So you'll need to find a probability there. And then there's a second follow-up question related to that. So I would love for you to pause the video and give these a try. Okay, so this idea that most people are sitting at 0 loss and just a couple people are way out over on the side tells me that this is a right skewed distribution. So if I only sold 12 policies, I would be really concerned about that because I haven't met the criteria for the central limit theorem to kick in. And so I have no idea how this is going to pan out, if I'm going to make money or my company is going to go bankrupt. So that right skew is definitely a concern. If the company sells 10,000 policies, can it safely base its rates on the assumption that its average loss will be no greater than 136? Okay, so for this one, we do need to find that sampling distribution. Since we're over the size of 30 with 10,000, the central limit theorem kicks in, so we're going to get our normal distribution. The law of large numbers tells us that we're still going to have that same mean of 125. And then we do need to adjust that standard deviation by taking the 500 and dividing by that square root of 10,000. So that gave me a standard deviation of 5. So let's go over to Rossman Chance and take a look at what that probability is going to be. All right, so here we are in Rossman Chance. Let me get the 125 and that new standard deviation of 5 put in. We'll scale to fit, and then we're looking at the probability that the average loss will be no greater than 136. So I'll put 136 in for X. And so here I have a 98.6% probability that we won't exceed an average of 136. So that's pretty good. That's almost 100%. But we have a nervous investor who suggested an $8 rate increase to $144. How much safer are we going to be if we just charge people $8 more? So we'll change that 136 to be 144. Now we're virtually certain that our company is not going to go bankrupt because we're at 99.99% probability that we're not going to exceed how much we're charging people on that average. Okay, so hopefully you now have a little bit better understanding of how we're getting from a single individual to these samples and finding some probabilities about these samples. And now that we have this sampling distribution, we're ready to move into Unit 5, where we're going to find some confidence intervals and hypothesis tests. And those really depend on this backbone of the sampling distribution to make that happen.